Hi, welcome to another mini lecture on pre-calculus. Today's topic is finding the final amount in a word problem on continuous exponential growth or decay. In the previous lecture, we had the same issue, and there the focus was on financial issues. That is, if there is a interest rate based problem and we are applying the uh, continuous exponential growth to it, um, the formula there was the amount on the account was the original principal times exponential of r times t. So over there, the meaning of these ingredients: r is the interest rate, p is the original principal, and a is the amount on the account. Well, exact same formula and concept is applied to a very large variety of topics. We are going to look at two cases today, one of them related to radioactive material and the other one bacterial growth. Both of them follow a similar formula. It's just that the meaning of the ingredients are going to be different. And in the case of a decay, in case of a decay, we are going to have a negative r, or if you wish to make it explicit, a is p times the exponential of minus rt, and r is the decay rate. And in case of the growth, a is p times exponential of rt, where r is the growth rate. So r is decay rate in decimal, and in this case r is the population growth rate, and that's again in decimal. Explanation of these formulas and other applications is going to show up in your course on differential equations. So after pre-calculus, you're going to take calculus 1, then calculus 2, then linear algebra, and after that comes partial differential equations. In that course, they're going to have many more examples and explanation of where the formulas themselves come from. Right now, we're just learning the mathematics of it. So, in case of radioactive substance, you can have some material that disintegrates by itself and loses a percentage of what it is to some other material. In that case, for the decay problem, that's the formula to use. So we have a sample of radioactive substance that has an initial mass of 487 kilograms. That's like the original investment. That's your principal. Here is just the material, the amount, the weight of the substance. And it decreases, so that's a decay. Continuously, that's a continuous compounding problem we had before, which gives us this formulation of exponential of RT. It has a rate of 9% per day, and then we are waiting just 2 days, so we are giving a rate of 9%, so R is minus 0.09, P is 487, and T, we have to pay attention that the unit that is used is the same in both cases. Otherwise, you have to do a conversion to get them to be the same. So here T is 2. So the amount of this radioactive substance that's going to remain after 2 days is, so we are going to use this formula now. So it's going to be P is 487, and then exponential of minus 0.09, that's my R, times T, which is 2. And again, as we said in the previous video, you enter this completely on your on the LX calculator in a single go, as opposed to doing it piece by piece. That's what he's saying. Do not round any intermediate calculations. If you try to multiply in one stage and write it on a piece of paper, and then do an exponential of that, and again write that on a piece of paper, and typically keeping two decimal places and such, it's possible that your final answer will not be correct. So make sure you do the rounding to the required degree. Here's the round to the nearest tenth, and you'll be all okay. Here's a similar problem for a bacteria. This formula that we have for growth applies to many population problems. If you have a population that grows without being hindered by anything, then the population at time t is the original population times the exponential of RT, where R is the growth and T is the length of time you have waited. So here's the population problem. It says it has a growth rate of 17%, so R is 0.17. This one, you notice is per hour. We have an initial population of 966, so that is 966. And it says find the population after 6 hours. So 6 hours means T is equal to 6. If I had said after 1 day, just remember that 1 day would be 24 hours. So whatever time is given has to match the unit that you have here. Just convert it to the same unit. So here A is P exponential of RT, positive now, 966 times exponential of 0.17 times T is 6. Again, you calculate all of that on your calculator in a single go. Okay, so that brings to end our conversation about exponentials and some basic facts about them. Now we are going to gear up for more advanced topics with respect to logarithms and exponentials. Okay, until then, good luck and God bless.